Meta-analysis is a research method used to combine results from multiple studies. It aims to provide a more precise estimate of the effect being studied than any individual study can. Think of it as a way to get a bigger, clearer picture of a research question by looking at all the available evidence. Meta-analysis is particularly useful when there are many studies on a topic, but the findings are inconsistent or inconclusive. By pooling data from multiple studies, meta-analysis can increase statistical power and provide more robust conclusions. This method is widely used in various fields, including healthcare, education, and social sciences. It helps researchers synthesize existing knowledge, identify research gaps, and guide future research directions. In essence, meta-analysis is a powerful tool that enhances the reliability and generalizability of research findings by combining data from multiple studies. Conducting a meta-analysis involves several key steps. First, formulate the research question by clearly defining what the meta-analysis aims to answer. This step guides the entire process and determines the scope of the study. Next, conduct a systematic literature search, systematically searching for relevant studies using predefined criteria to ensure a comprehensive and unbiased sample. This involves identifying appropriate databases, journals, and other sources. Then, screen and select studies by carefully evaluating the identified studies based on predefined inclusion and exclusion criteria. This ensures that only high-quality and relevant studies are included in the analysis. After that, extract data from the selected studies, including sample size, effect sizes, and study characteristics. This step really requires careful attention to detail and accuracy. Finally, analyze and interpret the data using statistical methods to calculate pooled effect sizes and assess heterogeneity. Interpretation involves drawing meaningful conclusions based on the statistical findings. When formulating the research question, it's important to be specific and focused. Clearly state the population, intervention, comparison, and outcome of interest. For conducting a systematic literature search, use multiple databases and search engines to ensure a comprehensive search, and develop a clear search strategy using relevant keywords and mesh terms. During the screening and selecting of studies, use a standardized form to screen studies and ensure consistency. It's a good idea to have at least 2 independent reviewers screen the studies to minimize bias. For extracting data, develop a data extraction form to ensure consistency and accuracy, and pilot test the data extraction form with a subset of studies. When analyzing and interpreting data, use appropriate statistical software for meta-analysis, and consider potential sources of heterogeneity and explore them appropriately. Mastering meta-analysis is crucial for researchers and practitioners in various fields. It enables them to synthesize evidence by combining findings from multiple studies to provide a comprehensive understanding of a research topic. It also helps increase statistical power, enhancing the ability to detect statistically significant effects that might not be apparent in individual studies. By improving generalizability, meta-analysis allows researchers to draw more generalizable conclusions by pooling data from diverse populations and settings. It can also help identify research gaps by highlighting areas where further research is needed, especially by pointing out inconsistencies or gaps in the literature. And of course, it guides decision-making by providing evidence-based recommendations for policy and practice based on a synthesis of existing research. By mastering the steps of meta-analysis, researchers can enhance the rigor, transparency, and impact of their work. This, in turn, contributes to the advancement of knowledge and improves decision-making in various fields.